Welcome to today's chemistry class. We continue with the stoichiometry and more concept. In this lesson, we are going to deal with the three of the parts. That is percentage yield, percentage purity, and percentage composition. So we are going to do them in that order. Let us start with percentage yield. And the first thing that we want to do is to define what percentage yield is. Percentage yield is simply the ratio of actual yield to the theoretical yield multiplied by 100%. That is what we call percentage yield, or that is how we define percentage yield. So if you find a question asking you to define percentage yield, exactly that is how you define it. Now, how does it look in terms of a formula? How do you calculate percentage yield, or how does the formula look like? So in this case, percentage yield is equals to actual yield divide theoretical yield multiplied by 100%. So this is exactly how the formula looks for percentage yield, and this is what we are going to use as we go on. So you might want to master this or to know this formula. Now, before we even go into the calculations, it's very important that we understand a few of the terms such as yield, because here we are talking of percentage yield. So what is a yield? So yield in chemistry is just the amount of product produced when a substance or substances react. So yield, we are talking of amount of products produced when substances react. That is what we call yield. Another term that we might want to know, since we are saying percentage yield is actual yield divide theoretical yield, we might want to expand or to look at what these terms stand for. And of course, pay attention on this particular part, because I'll get to unlock some of the terms or some of the things that you need to understand in order to know what you're asked or to answer the questions correctly. So the other term that we can look at is actual yield. Actual yield is also called experimental yield, or the amount obtained. Have you gotten that? So it is called actual yield, theoretical yield, experimental yield, also amount obtained. I think obtained is the term that you are going to come across commonly. So when you are told the mass obtained, just know that that mass is actual yield. Then the other one is theoretical yield, which is also called expected yield. So this is just what you expect, not really what you get, but what you expect, your expectation. So this is the maximum amount of product calculated from the measured amount of a given reactant using the balanced chemical equation and the Moore concept. So in other words, this one is the calculated mass. Okay, so three of the terms that you need, three of the three of the ways this one can be called. So one is theoretical yield, expected yield, or calculated mass, or calculated yield, because this one you normally calculate it. You cannot calculate the actual yield. It is what is obtained, but for theoretical yield you calculate it. Okay, so now again, the other thing that you need to understand to make sure that what you are doing is correct, or what you are calculating is correct, always the actual yield is less than the theoretical yield. Okay, so you are not going to have 100% yield when you do the experiment. So in this case, the expected yield, the actual yield is always less than the theoretical yield. Maybe you might find the question, what is the reason why the expected or the experimental yield or actual yield is always less than the theoretical yield or the expected yield? And these are some of the reasons. So as you are doing the reaction, as you are preparing to do the reaction, of course there's transfer of reactants, all those. So one of the reasons is that loss of reactants or product during transferring. So you might lose some products or reactant during transferring from one vessel to another. So that is one of the reasons why the actual yield is less than the theoretical yield. Then B, evaporation of reactants or products. So some products are volatile, they might evaporate, and hence it affects the amount of the actual yield. Okay, then the reactant may be reversible. So when the reaction may be reversible. When the reaction is reversible, which means after the products have been formed, then now products start forming back to the reactant. So this one can affect the amount of product obtained. Then reactants may fail to react completely due to impurities. So you might have reactants that have impurities. So only the pure mole will react, but of course the impure substance will remain, and therefore affecting the amount obtained. So these are some of the reasons why the actual yield is usually less than the theoretical yield. Put into, make sure that you understand this part. Okay, so let us get into the calculations now. And here is the first question that we are going to look at, example 1. So the question reads, magnesium oxide react with a dilute acid as shown below. So this question, I've just extracted it in the past paper. So please make sure that you follow keenly, because this is how the question comes. So magnesium oxide react with a dilute acid as shown below. As you can see, the equation, the chemical equation. But please, in most instances, you are asked to write the chemical equation as a first question. So that particular part, you need to know it also. The video is available just on that part, how to write chemical equation and also balancing. Now, 600 grams of magnesium oxide was reacted with 980 grams of dilute sulfuric acid. Determine the limiting reagent. So this is the first question, determine the limiting reagent. And I should mention that this part we are going to go through it as a recap of what we've looked at already. We did, there is a recording on determine the limiting reagent. So if you are not aware, or this is the first recording that you are watching, you might want to go through the limiting reagent part. Okay, so let's go into it. So in order for us to determine the limiting reagent, we really need to understand what a limiting reagent is. As the name suggests, the limiting reagent is just a reactant that is in short supply, or in other words, the reactant that finishes fast. So that is simply how you define a limiting reagent. Now, since it's a reactant that finishes fast, for us to determine the limiting reagent, therefore we target the reactants. As you know, these on the left side are called reactants, these are called products. So you only determine the limiting reagent on the reactants and never on the products. So how do you do it? You find the number of moles of the reactants. So we are going to calculate number of moles. So number of moles of magnesium oxide is the one that we are going to start with. Now, in order for us to calculate number of moles, also there's a recording on calculating number of moles. You look at the information that you are given for that particular compound. So in this case, magnesium oxide react with dilute acid as shown below. Let us look at this. 600 grams of magnesium oxide. So mass is given on magnesium oxide. So we are going to use mass over molar mass. So in this case, the mass given is 600 gram. Divide the molar mass of magnesium oxide. If you want to look at magnesium oxide, the molar mass is the oxygen 16, then of course 24 for what? 24 for magnesium. Then you add them, it give you 40. So 40 gram per mole. If we are to cancel here, what are you going to find? The final answer here, 600 divide 40, it is giving me 15 mole. So the number of moles of magnesium oxide is 15 mole. Then of course we need to find the number of moles of sulfuric acid. Okay, number of moles of sulfuric acid. What are we given on sulfuric acid? So 980 gram of dilute sulfuric acid. So also we are given the mass. So mass over molar mass. So in this case, what is the mass given? 980 gram. Divide. What is the molar mass of sulfuric acid? So if you were to look at sulfuric acid, is like this. Oxygen, we have what? 4. So 4 multiplied by 16. 1 oxygen is 16. We have 64. Then sulfur is 32. Then of course we have hydrogen, which is 2. So we have 2. So in other words, we are adding 64 plus 34. 64 plus 34 is just the same as 60 plus 60, that is 90. 90 plus 8, that is 98. So here we have 98 gram per mole. I guess you have no problem on this. And also there's a part, I think the part for finding the introduction, that is where we'll find the relative molecular mass, relative atomic mass. I did that part, you might want to go through. So if you divide here, it's just the same as 98 and 98, which is just 1. So we have 10 more. Okay, so the number of moles of sulfuric acid is 10. Now after you are done with this, you might want to divide, or you need to divide the stoichiometry coefficient, or the numbers in front of this compound. You divide the number of moles. So on magnesium oxide there's a 1. So 1 divide, or 15 divide 1, you still have 15. Then in front of sulfuric acid there's 1 also. So 1 divide that, you have a 10. Now if you had a 2 in front here from the balance equation, we assume this equation is balanced. Yeah, it is balanced. So if there was a number there, if there was a 2 here, you divide with a 2. I guess you get that part. Okay, so in this case, after doing all that, the one with a smaller number of moles is the limiting reagent. So in this case, we have 10 more and 15 more. So the one with a smaller number of moles, of course, is sulfuric acid. And therefore, sulfuric acid is the limiting reagent. So you just write a sentence: sulfuric acid is the limiting reagent. So don't guess, or do not guess which the limiting reagent is, but instead you need to determine it by the calculation. That is the sure way of doing things. All right, let us go to the question B. Calculate the mass of magnesium sulfate that was obtained at the end of the reaction. Now listen very carefully. How do you determine the mass of magnesium sulfate? So magnesium sulfate is MgSO4, which is this one, which is on the product side. Now, in order for you to find the mass of the product, you need to have one of the reactant that you are forming a ratio with. And in this case, you get the limiting reagent, because when the limiting reagent is done, then the reaction stops. In other words, the limiting reagent determines the amount of product formed. So first, before you even calculate this question, you need to determine the limiting reagent. Okay? So I'm sure if you find the long limiting reagent, it might affect your calculations. So the limiting reagent, we found sulfuric acid. So you're going to form a ratio of sulfuric acid to magnesium sulfate. In this case, let us use mass to mass. And mass to mass requires us to find the relative atomic mass of this one, of which we found it already, which is 98. We treat it as mass, gram. We are using the units of gram here in the calculations, as you can see. Then 98 gram of sulfuric acid, when it reacts with magnesium oxide, it produces what mass of magnesium sulfate. So you find also the relative formula mass of magnesium sulfate. In this case, oxygen 16 multiplied by 4, it will give us 64. Then sulfur, which is 32. Then of course magnesium, which is 24. So in this case, you are going to add 24 plus 32 plus 64. And what are we able to find? Okay, what are we able to find? So let us just add quickly. So we are going to say 24 plus 32 plus 64. So in this case, I'm finding 120. So 120 gram. Then let us look at it now. What are we finding? Calculate the mass of magnesium magnesium sulfate. So here we are going to put X. We do not know the mass of magnesium sulfate. Now look at this. 98 gram of sulfuric acid react with magnesium oxide to produce 120 gram of magnesium sulfate. What about now? What is the mass of given mass of sulfuric acid? What about 980? What about 980 gram? What would be the mass of magnesium sulfate? So here you cross multiply and you're going to have X 98 gram equal to 120 gram multiplied by 980 gram. Divide 98 gram, divide 98 gram. So 98 is just the same as 98, 1. So it's just the same as 10 multiplied by 120, which is 1,200 gram. Okay, so the mass of magnesium sulfate is going to be 1,200. Take note of that. Then let us proceed to the C question. 1,080 gram of magnesium sulfate was obtained at the end of a reaction. Calculate the percentage yield. Now look at this one. 1,080 mass of magnesium sulfate was obtained. Calculate. So the keyword here is obtained. What did I say? Where we are coming from? Obtained, we said, is the actual yield, or what you are given is the actual yield. You never find the calculated yield in the question. So every time you're asked of calculating the percentage yield, the mass that you're given is the actual yield. So calculate the percentage yield. So percentage yield is equals to actual yield divide theoretical yield multiply by what? 100%. Now look at question question B. Calculate the mass of magnesium sulfate. Here what did we do? Calculate. So the calculated mass is called what? So this is called the theoretical yield, the calculated one. Then obtained is called the actual yield. So therefore we are going to use 180 gram divide 1,200 gram multiply by 100. What are we going to have here? So after calculating here, we are going to have 90% as the percentage yield. So 90% is the percentage yield. So that is how you work it out. I guess up to this point we do not have a problem. All right, let us proceed to look at percentage purity. What is percentage purity? So percentage purity is the ratio of the amount of the pure substance in the sample divide the total amount of the sample multiplied by 100. Percentage purity is the ratio of the amount of a pure substance in the sample to the total amount of the sample multiplied by 100. So in terms of formula, that is how you look at it. Let us go into the calculations. So 8.0 gram of impure sodium hydroxide, so we have something impure here, solution was reacted with exactly 40 centimeter cubic or cubic centimeter of 2.0 mole per decimeter cubic of sulfuric acid. The first question is write the balanced chemical equation. So we start with the basics. Writing the balanced chemical equation shouldn't be a problem. What is reacting? Sodium hydroxide and sulfuric acid. So sodium hydroxide is a base written as this, which is aqueous. React with sulfuric acid written as this, which is also aqueous. What is produced? That is sodium hydroxide, sodium sulfate. This is a base and acid reaction plus water. Water is a liquid. Is this a balanced equation? No. So in this case, for us to balance it, we need to make sure that the atoms on the reactant, each of them are balancing with those on the product. So sodium we have 2 this side, here we have 1, so we put a 2 here. Sodium 2, oxygen we have 2 plus 4 of these, 6. But this side we have 4 and 1. Hydrogen, this side we have this 2 and these 2, 4. So in this case we have only 2, so we put a 2 in front of water. Okay, so now is this balanced? Yes, it is balanced. I guess there's no one having a problem with balancing equation. So this is the balance equation. Then the next one, which is the second on the first one, construct the net ionic equation for the reaction. Now net ionic equation, we get it from the balance. So if you balance it, then you'll be able to write the net ionic equation. But please, if you didn't, it will be very difficult for you to write the net ionic equation, because in this case you just have to split the balance equation, and in this case you only split those that are in aqueous state. You leave out those that are in other states such as solid, gas, and also liquid. So this is what we have from the balance equation. So I can split the first one, sodium, will be split like this, which is aqueous, plus 2 hydroxide. So this 2 multiplies everything here, so 2 hydroxide, which is aqueous, plus sulfuric acid, it will be like this, which is aqueous. This is positive, please, plus sulfate, like this, which is aqueous. Then this side we are going to split just sodium, so 2 sodium positive, which is aqueous, plus sulfate negative. Then at the end we have 2 water molecules, so water will not split. Okay, so 2 water molecules. Now the next thing, you cancel out those that are common on the reactants and products, so sodium and sodium. We have sulfate and sulfate. What is remaining is 2 hydroxide ion, which is aqueous, plus 2 hydrogen ion, which is aqueous. Then on the side is 2 water molecule. So this is the net ionic equation, and I hope there is no problem up to this point. Okay, so let us proceed to look at the main part now. Calculate the number of moles for sulfuric acid that reacted with 8.0 gram of impure sodium hydroxide. Calculate the number of moles of sulfuric acid that reacted with impure sodium hydroxide. So all these, if you can see, they are on the reactant side. So we are going to form the ratio of sodium hydroxide, which is impure, to sulfuric acid. Now they are saying calculate the number of moles of sulfuric acid that reacted with. Now, not even this one, please. Let us look at what we are given in terms of sulfuric acid from the first. So 8 of sodium hydroxide reacted with exactly 40 centimeter of. So we are given the volume of sulfuric acid, which is 40 centimeter cubic and 2.0 mole per decimeter cubic. Okay, concentration. So in order for us to calculate number of moles, we are going to use number of moles is equals to concentration multiplied by volume. The concentration is 2.0 mole per decimeter cubic, but the volume is in centimeter cubic. We need to convert it to decimeter cubic. So volume is equals to 40 centimeter cubic multiplied by 1 decimeter cubic is out of 1,000 centimeter cubic. Let me just write it nicely. Out of 1,000 centimeter cubic. So it's just the same as 40 divide 1,000 then decimeter cubic, which gives us multiply by 0.04. I guess I've gotten it right. 0.04 decimeter cubic. So if we are to multiply this, the number of moles of sulfuric acid, what is it going to give us? 2 multiplied by 0.04. 2 multiplied by 0.04, it is giving us 0.08 mole. So this is the number of moles of sulfuric acid. Okay, then find the mass of pure sodium hydroxide from the impure solution that reacted with 40 centimeter cubic of sulfuric acid. Now, to find the moles of the pure one, we need to form the ratio of sodium hydroxide to sulfuric acid. So the number of moles of sodium hydroxide that reacted with sulfuric acid are the pure ones, because we are saying this was impure. So only those moles that reacted are the ones that we are interested in. But how are we going to find them? If you look at the balance equation, there's a 2 in front of sodium hydroxide, so we are going to use mole to mole. So which means there's a 2 here. This means that 2 moles of sodium hydroxide produces what? 1 mole of, 2 moles of sodium hydroxide react with 1 mole of sulfuric acid. What about 0.08 moles of sulfuric acid? The one that we found. What would be the mole of sodium hydroxide? So X here is going to be 2 multiplied by 0.08, which gives us 0.16 mole. So these are the number of moles of pure sodium hydroxide that reacted. Okay, these are the numbers of moles of find the mass of pure. Okay, so these are the number of moles of pure sodium hydroxide. Then determine the percentage purity. Now remember the formula percentage purity. Where is it? So it is right here. Percentage purity is equals to amount of a pure substance in a sample divide the amount of impure substance. So we need to find the amount of the pure substance. The impure we've already found. So percentage purity equals to amount of pure substance. Okay. Then total amount of the sample multiply 100. Okay, so amount of total sample, if you look at the question, we are given 8.0 gram of impure sodium hydroxide. So it was given. Okay, so it was given, which is the down part was given 8.0 gram. But what about the amount of a pure substance? For us to find the amount of the pure substance, we have number of moles of the pure sodium hydroxide, which is 0.16 mole. Remember, we calculated them. Now, if you have the number of moles, we can use the formula number of moles is equals to mass over molar mass and find the mass of the pure. So we're going to say mass is equals to number of moles multiplied by molar mass. Okay? Number of moles is 0.16 mole multiplied by the molar mass of sodium hydroxide, oxygen 16, hydrogen 1, sodium 23. So you have 24 plus 16, which is just the same as 40 gram per mole. So in this case, if you multiply, what are you going to have? 40 multiply 1.0, that is 40 multiply 0.16. Here I'm getting 6.4. So mass of pure sodium hydroxide is equals to 6.4 gram. So I'm going to say 6.4 gram multiplied by 100. In this case, what are we going to find? Divide this one by 8. It's giving me 0.8 multiply 100, which is 80%. So percentage purity here is 80%. I guess you've gotten what we are doing. All right, let us look at the last part now, that is percentage composition or composition by mass. Now, what is composition by mass? So is the ratio of the amount of each element to the total amount of the element in the compound multiplied by 100%. So this is how we calculate percentage composition. So composition of an element, mass of the element, divide molar mass of the compound, multiplied by 100%. Let us look at this question. Urea, which is this one, and ammonium nitrate, which is this one, are two nitrogenous fertilizer used by farmers. Calculate the percentage composition of nitrogen in urea. So percentage composition of nitrogen equal to, okay, percentage composition of nitrogen, what did we say is the formula? Molar mass of element, molar mass of element, divide, what are we dividing with? Molar mass of a compound. Molar mass of a compound. Multiply by what? 100. So nitrogen, what is the molar mass of nitrogen? Look at this compound. How many are the nitrogens? Look at this one. So nitrogen is right here. And how many are they? These two multiplies also. So nitrogen, one is 14, but multiplied by there are two of them, which gives us 28. So nitrogen here is 28. Divide the whole of this. So we've already found for nitrogen, which is 28. We can add the one for hydrogen, which is 4, because hydrogen here is multiplied. So we can add 4. Then of course also we can add for oxygen, which is 16. We can add for carbon, which is 12. If we were to add this, so let me just say 28 plus 4 plus 16 plus 12. What is it giving me? I'm getting 60. I don't know if that is what we are able to get. Otherwise, I'm getting 60. Then multiply by 100. So 28 divide 60. Then multiply by 100. So this one I'm able to get 47%. So the percentage composition of nitrogen in urea is 47%. All right, I guess you've gotten something up to this end. Otherwise, we've come to the end of the lesson. If you are interested in the online lessons or physical lessons, you can contact the number 0976 402563. If you are coming for our physical lessons, we are found in Lusaka, that is Kawata area near Kawata Primary School. So you can still get in touch for directions. Otherwise, see you in the next one.